Welcome to the Quantanix YouTube channel. This is the NextLayer podcast, episode 6. Today's title is The Invisible Internet, Birth of a Hyperconnected World. So here's a thought. What if the internet we tap into every day, the endless scroll of websites, the constant buzz of apps, what if that's only scratching the surface?
That's exactly what we're diving into today.
We're plunging into this really fascinating world of invisible technology and hyperconnectivity.
And these aren't just buzzwords, right? They're fundamental shifts.
Definitely not just trends. These are game-changing shifts in how we experience the digital realm. We're going to explore how they've evolved, the impact they're having right now, and honestly, some truly surprising things they might lead to.
Yeah, the implications are pretty significant.
That we've looked at quite a bit for this, sifted through expert analysis, some really forward-thinking reports to kind of pull together the key pieces for you. Okay, so let's kick off with this idea of invisible technology. What does it actually mean for us?
Well, fundamentally, invisible technology signifies a real shift. It's a move away from the computers we used to, see and interact with directly, the clunky hardware, the distinct interfaces. The trend now is towards technology that's so integrated into our lives, into our environments, that it largely disappears from our conscious awareness.
That sounds almost philosophical. Is there like a specific way of thinking behind this?
Absolutely. It draws quite a bit from phenomenology, actually, which is all about how we experience the world around us.
Right.
Researchers talk about things like invisibility in use. Think about your smartphone.
Okay.
You use countless features without actively thinking about the complex tech inside, right? It just becomes second nature.
Yeah, totally.
And then there's infrastructural invisibility. That's where computing capabilities are embedded in the environments we inhabit. Like a network that powers a smart building or maybe a city's traffic system.
Right, like the GPS in your car. You rely on it, but you're focused on the road, not the satellite signals or the software.
Exactly. You're focused on the task, not the tool. And this idea of technology fading away isn't exactly brand new, is it?
Yeah, it feels familiar. Wasn't there someone specific who talked about this early on?
You're probably thinking of Mark Weiser, a true visionary. He coined the term ubiquitous computing, or UbiComp.
UComp, that's it.
Yeah. He famously said that the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until we don't even notice them anymore.
How did he put it? Something about it being natural.
He described invisible technology as so embedded, so fitting, so natural that we use it without even thinking about it, which is, a world away from those early computers.
Oh, absolutely. Flashing lights, command prompts. Very different. So we've moved from these very obvious machines to something far more subtle. How has that vision sort of evolved?
Well, UbiComp, with its goal of integrating computers seamlessly into our surroundings, has kind of evolved into what we now often call ambient computing.
Ambient computing, okay.
The key here is making the technology truly frictionless, making our interactions effortless. It's not about literally not seeing a device necessarily. Yeah. It's more about what some call cognitive invisibility. The tech recedes into the background of our minds. Our focus stays on what we want to do, not on fighting with the tech to get there.
Like a smart thermostat. You set it and forget it.
Perfect example. It just maintains the temperature you like. You're not constantly fiddling with dials. The experience becomes the focus, not the gadget itself.
That makes perfect sense. Now, you mentioned a real-world example earlier, the Invisible Internet Project, or I2P. That sounds intriguing.
It really is. I2P is a fascinating initiative. It's actually been around since 2002.
Wow, that long.
Yeah, driven by a very clear vision to deliver full anonymity, privacy, and security at the highest level possible.
Okay, that's a bold goal.
It is. The idea, as its founders put it, was to build the internet that should have been. One less susceptible to the kind of monitoring and control we often see on the regular internet. Free from ISP control, essentially.
So it's like a parallel privacy-first internet running alongside the one we use every day. How does it actually work? How does it achieve that privacy?
Technically, I2P is a fully encrypted peer-to-peer overlay network.
Overlay network.
Yeah, think of it as a separate, secure layer built on top of the existing internet infrastructure. What's really clever, technically speaking, is its use of encrypted unidirectional tunnels.
Unidirectional tunnels. Okay, break that down.
Imagine data traveling down a one-way street, but that street is constantly changing and everything on it is heavily encrypted.
Got it.
This makes it incredibly difficult for anyone watching the network, say an ISP or an adversary, to trace the content of a message or figure out where it came from or where it's going. All the traffic stays within the I2P network layer itself.
That sounds like a very deliberate design for privacy.
Absolutely. Privacy by design is a core principle. The whole architecture is set up to hide the server from the user and the user from the server.
How does that work against, say, tracking patterns or censorship?
Because data is routed through many different volunteer computers on the network, the peers, it becomes extremely challenging to use techniques like traffic analysis. And as more people join and run I2P nodes, the network becomes more distributed.
Which makes it harder to block.
Exactly. Location-based blocking, for example, becomes increasingly difficult and less effective as the network grows. It's a really interesting approach to building a more private online space.
It really is fascinating to see that evolving alongside the mainstream internet.
Okay, let's switch gears slightly to the other key concept. Hyperconnectivity. What exactly are we talking about there? Hyperconnectivity describes the environment we're increasingly living in. It's where internet access and digital services aren't just available, but they're immediate, ubiquitous, really.
So constant connection.
Constant and seamless exchange of information between people, between businesses, and crucially, between machines and devices too.
And what's pushing this? What's fueling this massive surge in everything being connected all the time?
Well, several things are driving it. The sheer explosion in the number of mobile devices we all carry is obviously huge.
Sure.
Alongside that, you have the growing power of big data analytics and the pervasive influence of social media platforms. These have fundamentally reshaped how we interact, how relationships form.
You mentioned some pretty wild numbers earlier about just how connected we're becoming. Can you share those again? They really put it in perspective.
Certainly. Projections for, say, the 2030 to 2040 timeframe suggest we could see up to 1 million connected devices per square kilometer.
1 million per square kilometer.
Yeah. Compare that to current 4G LTE networks, which can handle maybe 60,000 or so.
That's a huge jump.
It is. And even back in 2022, estimates put the number of operational connected sensor devices globally at over 20 billion. This isn't just a gradual increase anymore. It's a massive qualitative leap in the density and nature of connectivity.
Almost hard to wrap your head around. And 5G technology is playing a big role here, right? It's kind of the enabler.
Exactly. 5G is critical. Unlike previous generations like 4G, 5G were specifically engineered from the ground up to support this massive density of devices.
And the speed requirements, too.
And the ultra-low latency requirements, the really quick response times that the Internet of Things, or IoT, demands. As 5G continues its global rollout, our society is just going to become increasingly reliant on these billions of connected devices. For everything.
Critical infrastructure, everyday routine.
Absolutely. It's really the foundational layer for many of these next-generation internet applications we're starting to see.
Okay, so we have this underlying trend towards invisible computing principles, technology fading into the background, happening at the same time as this explosion of hyperconnectivity, everything talking to everything else. Where do these two powerful forces meet? What happens when they converge?
They're converging to create what many in the field are calling the next generation Internet of Things.
Next generation IoT.
Right. It's where that idea of technology seamlessly fading into the background meets a world that is absolutely saturated with interconnected devices.
Can you give us some examples? Paint a picture of what this tactile IoT, sometimes called IIoT for industrial IoT, might actually look like.
Sure. We're seeing this technological convergence. You've got hyperconnectivity, obviously, but then you add advancements like edge computing.
Edge computing that's processing data closer to the source, right?
Right.
Not sending everything to the cloud.
Exactly. Bringing processing power closer to where the data is generated. Then you layer in things like distributed ledger technologies, think blockchain, for instance.
Okay.
And of course, artificial intelligence, AI, machine learning, neural networks. These allow for applications controlling robots, drones, autonomous vehicles.
Self-driving cars.
Self-driving cars, yeah.
Okay.
Enhancing our experiences with augmented reality, virtual reality. Think more intuitive digital assistants that don't just react, but maybe even anticipate our needs.
That sounds like a pretty significant jump in capability. And this move towards edge intelligence, processing data locally, that seems to tie directly back to that invisibility principle we talked about earlier.
It absolutely does. By processing data closer to its source on the edge of the network, rather than always going back to a distant, centralized cloud, you significantly reduce delays. Latency drops.
Makes things faster.
Much faster, and reduces the need for constant communication with remote servers. This makes interactions much more seamless, contributing to that feeling of technology just working without us having to actively, manage it. Devices can operate more autonomously, respond in real time.
It's interesting, though, that even with all this incredible technical sophistication, AI, edge computing, massive connectivity, there still seems to be this focus on the human experience.
That's absolutely right. And it's crucial. The emphasis in this next generation IoT is very much on human-centered design.
How so?
The goal is to create systems that interact with us, and even with other autonomous systems, in ways that feel natural, intuitive. Social capabilities are being built in making these technologies more accessible, more genuinely useful in our daily lives.
So it aligns with Weiser's original vision.
Perfectly. It aligns with that original vision of invisible technology serving human needs without demanding our constant attention or effort.
So, wrapping up this part, it really gives us a fascinating glimpse into where things might be heading. A world interwoven with technology, but technology that's often unseen, operating behind the scenes.
Precisely. We're on a path towards a world where the internet operates much more in the background, powering an environment of, truly unprecedented connectivity.
The foundations seem to be falling into place.
They are. You've got these encrypted P2P networks like I2P pushing privacy. You've got the 5G infrastructure providing the speed and capacity. And you've got edge computing distributing the intelligence.
Creating the conditions for technology that's powerful but maybe less intrusive.
Powerful yet unobtrusive. Making our interactions with the digital world potentially more fluid, less demanding.
But this raises some big questions too, doesn't it? Especially around things like privacy and control.
Huge questions. That level of ubiquitous connectivity, even if it feels invisible, makes privacy concerns much more acute.
How so?
Well, think about surveillance, data collection. When sensors and connected devices are embedded everywhere in our physical spaces, the potential for monitoring increases dramatically. Security becomes paramount.
I2P's model, that privacy by design, seems like one potential approach.
It's definitely one approach, focusing on anonymizing the network layer itself, but the broader questions remain for all these hyper-connected systems. How do we ensure data is handled responsibly? How do we maintain security?
And there's also this theme of decentralization bubbling up, isn't there? In both I2P and the next-gen IoT with edge computing.
That's a really interesting parallel. I2P is explicitly designed to be decentralized, people-powered, running on volunteer nodes to resist central control. And edge computing, by its nature, distributes processing power away from giant centralized data centers. It moves intelligence closer to the users and devices.
So does that suggest a potential shift in power dynamics? Away from the big dominant platforms, maybe?
It could. Distributed architectures, whether in networks like I2P or in IoT systems using edge and maybe DLTs, they have the potential to foster more distributed governance, perhaps give users more control over their data and devices. But it's not guaranteed. It depends how these systems are designed and regulated.
And one more critical point, accessibility. Does everyone get to benefit from this invisible, hyper-connected future?
That's the digital divide question, amplified. As these technologies become more integral to society, we have to ask about digital equity.
Access, affordability.
Exactly. Inclusion, accessibility for people with disabilities, affordability so it doesn't just benefit the wealthy, and also digital literacy. Do people have the skills to navigate and use these systems safely and effectively? These are major social challenges we need to address.
So to sort of pull it all together, this deep dive shows that the invisible internet within this emerging hyper-connected world isn't just a technical upgrade. It's a significant evolution in our relationship with technology itself.
Absolutely. The technical foundations are being laid in encrypted networks, 5G, edge computing. These create the potential for powerful, yet much less obtrusive technology.
But the real challenge, the ongoing work, is ensuring this infrastructure actually serves human needs and values.
Precisely. It means continued attention to privacy by design, pushing for equitable access, and always keeping human-centered development front and center.
It's about harnessing the potential. You mentioned I2P's goal, the internet that should have been. Maybe this convergence, if guided well, offers a chance to build something closer to that, something that enhances our capabilities while respecting our autonomy and privacy.
That's the hope, and perhaps the most provocative thought for you, the listener, to take away. As technology integrates more deeply and becomes less visible, how do we, collectively and individually, shape its trajectory? How do we ensure it truly empowers us in this hyper-connected era? It's something we'll all need to keep thinking about.
A lot to consider there. Thank you for joining us for this deep dive into the invisible internet and the birth of a hyperconnected world.
My pleasure. Always fascinating stuff.
Remember to like, subscribe, and stay tuned for more deep dives on the NextLayer podcast at the Quantanix YouTube channel.